Well, it's almost similar to the parabola, except you have two pieces, not just one. So your graph, it's either going to look like right now we're going to make the center at the origin. Then in the next section, the next video, we'll switch the centers, no longer on the origin. It looks like two hyperbolas. I mean, the hyperbola looks like two parabolas. So your graph is either going to look like this, or it's going to look like this. That's where your graph is going to be, two pieces. Before we looked at the parabola, but it was centered at the origin all the time. So it's like having two of them. Notice when it's like this one, crosses which axes? The x-axis. So that will be x squared over a squared minus y squared over b squared is equal to 1. What is A? A is the distance from the origin to the vertex, to here. So if I was to write the coordinates for this point, that's A comma 0. The coordinates for this point is what? Negative A comma 0. You'll have a focal point here. That focal point will have a coordinates of what? C comma 0. And 1 here. Negative C comma 0. So notice C will have to be bigger than A. Everyone see that? C has to be more than A. That's why here C squared equals A squared plus B squared. We didn't discuss what the significance of B yet, because you really don't see it yet till I give you an example. And if it's up and down like this, instead, notice crosses the y-axis, not the x-axis. So that becomes y squared over a squared minus x squared over b squared is equal to 1. So this is the distance. This is A here. That's the vertex. Is 0 comma A. The other vertex is right here. 0 comma negative A. So A is the distance. That's what A is. That distance.
A is the vertex, right?
A is the distance from the origin to the vertex.
Okay.
Yep. So this is A here. Where's my focal point? It's going to be up here. And the coordinates for that will be 0 comma C. Another one here. 0 comma negative C. So again, C squared equals A squared plus B squared. What's the significance of B? Well, a parabola looks like something like this, but how tight is it? What is B going to do for us? It's going to give us actually a line. It's called asymptote in a minute there, and we'll show you the significance of that, and that'll give us the slope there. Because we're trying to find out, should it be really flat like this, or should it be tight, the picture? How do we know? And A comes in the picture, goes, wait a minute, you can draw a line going through the center like this, and that's your asymptote. What does that mean, asymptote? You approach that line, so that gouge is going to be bigger like this. And here it says, wait a minute, it's going to go like this, because you're approaching that line. Well, what's the slope of that line? The slope here, this is going to be what? The rise over the run. The rise is going to be B here, and the run is A. So that's where B comes in.
I have a question.
Yes.
Is this the same concept as the other other one, where if A is bigger than B, that tells us which.
Well, this is always, A is always the vertex, the coordinate for the vertex. So where it crosses the x-axis, if it crosses the x-axis at A, notice A is always on top of x-axis. If it crosses the y-axis, A on top of the y-axis, or below the y-axis.
Because I know sometimes they'll give it to you in like the x squared orientation. So they'll give you like x squared over 2 minus y squared over like 10.
Yep.
Or something like that. Then you
A is always, yep.
Because A will always be bigger than
A is, no, A is always going to be the plus one. So see the minus?
Yep.
The minus always goes with B here.
Okay.
A is always the plus. And if A actually, if you look above A, what's above A? Y is going to cross the y-axis. Here, what's above A? X is going to cross the x-axis. So if you're looking for something to recognize, that's what you want to look for. B is always a negative here.
Okay.
So A is always going to be the plus, and you look above A, and that will tell you it's going to cross the x-axis or the y-axis.
That wasn't the case for the other
No,
sections,
that's
right?
correct. A was the longer side for the other one, always.
Right, so
Not here. A could be smaller, could be bigger.
okay, just as long as it's positive.
Correct. A is the plus. I'll show you an example. And by the way, this asymptote or the slope for that could be plus or minus because there's two of them. One this direction, one that direction. And when it's in this direction, when it's up and down, you know, my slope for the asymptotes, the slope is going to be backward here. One is plus, one is minus, but it would be A over B. Now, I don't graph them with the slope. Well, I do actually, but not the way we do this slope here. I'll show you how I do them. Because to me, that's a lot of math to remember. So I'll take a problem. So let me take a problem here. And quickly by looking at it, you should be able to tell me if it's going to cross the x-axis or the y-axis. X-axis. Y? Who's positive? The x. So I know it's going to cross the x-axis. So I know A squared is equal to what? 16, which means A will be what? Plus or minus 4, yes. So one value at 4 somewhere here. So if I use a ruler here, let's use 4. Where's the 1, 2, 3, 4? A little bit more than 4. I don't know. I can't tell. So many scales on this one. I'll get a plain ruler. Just have to aggravate this one. Uh-oh. So let's make it cross a 4. Let's make 4 units here. There's the origin. There's 4 right here. I don't know if you can see it on the screen. So that's where it's going to cross. The other one, 4 units this way. Right here. So it's going to go to the right and go to the left. Again, how tight the graph is. Because it could be multiple pictures here. I'll use a pencil so I can erase it. Well, could it be something like this? Could it be wider? I don't know. We don't know the answer to that. So what do? We look at B. What's B squared equal to? 9, B equals plus or minus 3. So let's go up 3 units and down 3 units. Up 3, which is right here, and down 3, right here. And what I do is normally I build a box, going through all these 4 points, a rectangular box. Here we go. Then going through this, going through that. I got it now. This is my asymptote right there. Can you see it? This is one line, and there is another line. So what does that mean? So when you graph this, I don't need the stuff here. I don't need here. Trying to figure out which way is it going to be. Let me take a thick marker if I have one here. It's going to make noise there probably. Okay. You're going to go through this point, and it's going to approach this one. That's my graph. So that's what B and A let me figure out, how tight the graph is going to be. Notice my slope here, that's the line, the slope is the rise, which is B, over the run, which is A. So for this, the slope,
Could you shift the paper a little bit? Thanks.
the slope is equal to what? 3 over 4. But the slope of this line, it's negative, because it's coming down. This is my vertex here. And the coordinate for that, remember A is 4, so that's a negative 4 comma 0. And the coordinate for this vertex is 4 comma 0. Where's my focal point? My focal point is going to be here. And there is one here. So to figure the focal point, you need C. C squared equals what? A squared plus B squared. A is what? 16. B is what? 9. C squared equals 25. C equals plus or minus 5. So the coordinates for this focal point is 5 comma 0. And this one is what? Negative 5 comma 0. Now the distance from the vertex to the vertex, which is twice A, that distance from here to there is known as the transverse axis. And the distance from this point to that point, from down here to there. Remember, this is what? 0 comma negative B, and this is 0 comma B. The distance from that point to this point, which is twice B, is known as the conjugate axis. So if you hear the word conjugate axis, that's twice B. Transverse axis, that's twice A. The question is B always the smaller number and A was always the bigger number? And I says no. That was the question we got early. So A could be the smaller number or B could be the smaller number. In this example, B was the smaller number. Now I can reverse that. I can reverse that problem and I'll give you this one. I'll do y squared over 4 minus x squared over, I don't know, 16. Now this is a hyperbola. It's going to cross which axes? The y-axis. The y-axis. A squared is what? 4. A equals plus or minus 2. So that's 2 units up, 2 units down. That's where your vertex is. 2 and 2. That's where my vertex is. Now b squared is equal to what? 16. B equal plus or minus 4. That's a 4 here. That's a negative 4 here. Again, let's make our box. Now I get my asymptote. It's going to run diagonal, going through the center.
Is the a squared equals 4, or is it just a equals 4?
A squared equals 4. So here's my conjugate, my asymptote. That's the first asymptote. This will have a positive slope. And this is my other asymptote. So these are my two asymptotes. This is my vertex. Going to start here. Again, my graph then will look. You start from this point, and notice how wide it's going to be. And down here, that's what the graph is going to look like. So B could be bigger, A could be bigger. So the vertex here, the distance is A. A is 2 units. So the vertex here is 0, comma 2. That's the first vertex. The other vertex here, 0, comma negative 2. Now I got a focal point somewhere here. I have no idea how high, but I got a focal point here and I got a focal point there. What is the coordinates of that focal point? The distance from the origin to the focal point is C. Or, yep, C squared equals A squared plus B squared, which is what, 20? C equals the square root 20. 20, you can break it down to 4 and 5. Yep. 2 the square root of 5. So one of them is going to be 0, comma, the x value is 0, the y value, 2 the square root of 5. And the other one, 0, comma, negative 2 the square root of 5. The transverse axis that's twice A. That's the distance from the vertex to the vertex, which is what? 4 units. The conjugate axis is what? The distance from this end to that end. That's twice B, which is 8. You want the slope of these asymptotes? You want the slope of them? One is going to be positive, one is going to be negative. Notice this one is positive, this one is negative. It is the rise over the run. The rise is A here, the run is B in this example. So it's plus or minus 2 divided by 4, which is what? 1/2. You go up 1, 2 to the right. I find that's the easiest way to graph them, by making the box. Do you have to make the box? Our book does it actually, but you don't have to. You can use the slope here. You know it's a straight line going through the center. Once you know the slope, you draw these two lines with that slope, and that's your asymptote. I like the box. I'll be the first one to admit. Now, what will happen every once in a while, we don't give it to you looking like this. We like to see it looking like this. But sometimes we play games with it. So ideally, you want it to look like this, where that number is 1 at the end. Because if that number is 1, it's in the standard form. Well, here we go. Playing games. Let's look at this. That doesn't look like a 1 in it, on the right side. So what do we do then? How do you make that a 1?
Divide by 36.
Yep, divide by 36. Divide this one by 36. Divide this one by 36. Divide this one by 36. Then it will look like what? X squared over, how about 9? Minus y squared over what? 4. Now that matches the standard form. We know it's going to cross which axes? X-axis. Notice the center is where? At the origin. For the ellipse, the parabola, and the hyperbola, we've been dealing with the center of the origin. In the next section, we're going to change that. In the next video, we're going to make the center anywhere. So here we go. A squared equals 9. A equals plus or minus 3. B squared equals 4. B equals plus or minus 2. So that's where the vertex, at 3. There's the 3. 3 to the right, 3 to the left. So this will be what? We said 3 comma 0, negative 3 comma 0. Now b squared is what? 2? Go up 2 units and down 2 units. B squared is 4, b is 2, right? So that's these 2 points. 0 comma 2, 0 comma negative 2. And now make your box. There's my box. So my asymptotes again, let me use a different color here. Diagonal through the box, center of the box. That's one of them. The other one is down here, which is crosses which axes? the graph? The x-axis is going to cross here and cross there. That's what the graph will look like. Again, I just got to find the focal point here and the focal point here. C squared equals A squared plus B squared. C squared equals 13. C equals plus or minus the square root of 13. So that's negative the square root of 13, and the y value is 0. And this one, the square root of 13, comma, y value 0. If they ask you for exact number, you can leave it the square root of 13. Don't try to use the calculator there for that. Transverse axes. What's the distance from vertex to vertex? Is it 6? From here to here. Conjugate axes. The distance from here to here, that's twice b, which is 4. That's all about hyperbolas. Again, all the problems I did, every one of them, where was the center? At the origin. Is it always going to be there? No. So let's see the last case. We're going to change the center is no longer the origin. We're going to repeat all the lecture, like the ellipse, the parabola, hyperbola, but the center is not going to be at the origin. So I'll stop this video and I'll start the next one.